All right, let's go over our water quality assessment here. So let's start off with number one. Make sure I've got my red pen on. So number one, again, what I like to do with these questions is I like to find the first definition that I really know 100% for sure, and then narrow it down from there. So I know for sure that this first one right here that I just started, so measures the clarity or how clear the water is, that is D, or turbidity. So we can cross that off. Measures how alkaline or basic or acidic the water is, that is C, or pH. And then we have let's see, we have measures the number of nutrient compounds in the water. I might not be so sure about that one, but then when I look at the last one here, measures the degree of heat present in the subject or object using a thermometer. That is temperature, which leaves A to B nitrogen and the phosphorus test. So C, D, A, B for this one here. Now for number two, I took samples myself of the three sets that were out for the class to use. The temperature ranged from about 20.0 degrees Celsius to about 22.0 degrees Celsius, depending on the time of the day that it was taken. And that was for both of the samples. 22.0 degrees Celsius, so as long as you fell approximately within that range. And then the pH, this ranged a little bit for sample A. I saw as low as 6.8, and then as high as 8.6, and it actually varied a little bit depending on which probe you were using. And that's why I tested it with different probes in each of the samples, and but on average, like, it was right around 7 for most of those. And then while the pH for sample B was much narrower, it was between 3.0 to 3.3. And then turbidity, sample A was very, very clear. That was a 1, while the turbidity in sample B should have been a 3 using our scale. So for pH and temperature, guys, let me change my ink color here. For pH and temperature, you guys were using the probe. And as I watched you guys do these sample tests, I saw some common errors. So I want to go over how to properly, take these or use that probe. The first thing that you need to do is you need to take the cap off. All right, this was the biggest issue that I saw. This is the biggest issue I saw. I saw people sticking the probe in with the cap still on. That's not going to do anything. So you need to take the cap off, and then you can place in the sample. And then step 3, you're going to gently, keyword there, gently, that's a weird N, gently swirl, okay, for 5 seconds. And then you can read your results. All right. Looking at number 3, okay. So again, I did look at the ranges here for number 2. So as long as you fell about within those ranges, you got that correct. But let's look at number 3. So Dr. Gonzalez has a freshwater fish tank that includes goldfish and other community fish next to a space heater in her house. She tests her fish tank every week and the temperature is always changing. What is wrong with where Dr. Gonzalez placed her fish tank, and why is this harmful for the fish? So the first thing it wants to know is what is wrong with where Dr. Gonzalez placed the fish tank. So with the fish tank, being next to a space heater, it is causing the tank temperatures to fluctuate. So if you remember from our readings, you want to have your tank in a place where it's not being blasted by an AC vent. You want it to be not next to a space heater, not next to a air ducts or anything like that, where it's going to turn on and off and cause the tank temperature to rapidly fluctuate. And the second part of this, so why is this harmful for the fish? It is harmful for the fish. It's harmful for the fish because fish have a set temperature range they like to live in. And so if it gets too hot or too cold, or if that temperature rapidly fluctuates, it stresses the fish, okay? So too high or too low or quickly changing water temps or temperatures will result in stressed fish and possibly death. All right. Let's look at number 4. So this guy Drake measured his fish tank filled with common goldfish and other community fish. His data measurements are shown below using the normal parameters. What is wrong with his fish tank and how can Drake fix it? So there are 2 things that you could have said that are wrong with the fish tank. The first are the nitrogen levels. And the second is turbidity. So if we look, our nitrogen is over here at 20 parts per million, and the turbidity is at 4, so it's very cloudy. And then how we fix this, guys, is water changes. So really, as long as you said to fix both nitrogen and turbidity, water changes would be necessary. All right, and finally, looking at our mastery question, number 5 here. So this came from one of our readings. So an increase in carbon dioxide or CO2 in the atmosphere causes what change in the ocean? Give one example of how organisms are affected by this change. And then, so the first thing that it's asking is what is this causing? So the first thing, okay, so our first part of this question, so the ocean is absorbing about 85% of human CO2 emissions, causing acidification. Okay, so this pH, right? So our pH is lowering or becoming more acidic. Okay, so the ocean's absorbing up to ultimately 85% of those CO2 emissions, and as it's absorbing those CO2 emissions, this is causing acidification in the oceans, so that pH is becoming lower, it's becoming more acidic. So the second part is how are organisms affected by this change. There were a number of examples that you could have given. So you could have talked about how organisms, I mean, ultimately, as long as you discussed how organisms will struggle to survive, and so this is really what we wanted to look for. So organisms are going to struggle to survive, and likely a mass extinction will occur. All right, guys. So go ahead and make sure that you do your test corrections and then finish up your retake practice and then get in here to retake this test as soon as possible. All right, guys. I hope that you have a good rest of your day.